Welcome to another video with the TI-83 Plus graphing calculator. In this video I'm going to show you how to graph polar equations. Let's turn the calculator on. Normally if you're going to graph a regular function, we go to y equals, and we have a function in x and y, so we enter the expression over here. But in polar coordinates we have the units are, or I should say the ordered pairs are r and theta. A point in the polar plane is determined by an angle made with the positive x-axis, which is called the polar axis in the polar coordinates, and the distance that point is from the origin, or in polar coordinates that would be the pole, and that would be r. R could be negative or positive depending on whether the point goes along the terminal side of the angle or on the opposite of that terminal side. So the first thing we need to do is set the calculator to the appropriate mode. So let's go to mode. This one is set to functions. We do want it in radians for this to work out nicely, so that's already set to radians. Let's go to polar, POL, hit enter. I notice when I hit y equals, now I have it in terms of r, and then over here I have the rest of the expression, which will be in terms of theta. Instead of y and x, it'll be r and theta. Okay, so then we simply enter what we're going to graph. So here we're going to graph these equations here. So the first one is 3 plus 3, hit the cosine, and then hit x. But because I have it set to polar, and I know it's the calculator knows it's in angles, it gives me theta. So close the parentheses here. Now hit the graph, and this is what I get. Now in some cases this might not work out nicely like this, so what you want to do if you have problems like that, just go to zoom and use 7. That's the same thing you use for trig functions, so hit 7 and you get the same graph. So notice this is a heart-shaped graph called a cardioid. That's what it looks like. Okay, we'll clear this. Again, go to y equals. Now I'm going to enter the next one. This is 2, subtraction sign, and sine in this case. And I guess I should have cleared all of this. Let me clear this. This will be 2, again, subtraction, 3, sine, theta, hit the x, close the parentheses, let's graph. And notice again, if I go to zoom 7, get a similar thing. This is referred to as a Limacon. It has an inner loop. I don't get the whole graph here, you can't see it, so if you want to, you can go to zoom and scroll down to next one, zoom fit, hit enter. And it fits the graph to the screen. Okay, let's go again to the next one, clear this out. Let's enter the equation for C. So this is 4 minus 3 cosine theta, graph. Okay, let's do a zoom 7. There we have it. Now this is also a Limacon. In this case we don't have the inner loop. It's really a curve that surrounds the pole. And again, if you want to get the whole thing in there, go to zoom, hit enter. We could have just entered 0, would have given us the same thing. that's what the graph looks like. It's a curve that surrounds the pole. Okay, go to the next one. Clear this. So now for D, got R is equal to 5 sine of 2 theta. This time I'm going to go to zoom 7. Okay. This is what I get. This is referred, this one here, D and E, are referred to Rose curves. And the thing about the Rose curves, if you look at the coefficient for theta here, if the coefficient is even, then the number of petals, this one has 4 petals, which are simply loops that emulate from the pole. If this number here in front of the theta is even, then the number of petals will be 2 times that number. So in this case, 2 times 2 is 4. If the number in front, like number or letter E, is odd, in this case 5, then the number of petals will be just that number. So this one should have 5 petals when we sketch the graph. Okay. So let's go to this, clear it, enter the next one, 4 cosine 5 theta, close parentheses. Again, I'm going to go to zoom 7, and there we have it, another rose curve with 5 petals. Now these petals for all these rose curves are going to be equally spaced, so the distance between the axes of symmetry for these is going to be the same. Here, this angle is going to be the same. This angle right in here will be the same. Here or here, they're equally spaced around the pole. Let's clear this. Now this is a square, so similar to if you had x and y coordinates and you had a y squared here. In order to graph it in the calculator, you'd have to take the square root of both sides. You'd have a plus or minus, so you'd have 2 functions to enter here. Well, we're going to have the same sort of thing here. So if I take the square root of both sides, this will just give me r. On the right side, I'll have a positive 4 and a minus 4, and then the square root of the sine function. So I'm going to enter minus 4 and hit my square root, and then enter the function sine of 2 theta, 2, close parentheses, and then close parentheses, and then for the next one, enter minus 4. Well, I guess I already entered the minus 4, so this one will be positive. Let me delete this. This could have been positive and minus here, doesn't matter what order you put them in there, except as long as you put one positive, one negative. So this one then will be 4, and then second square root sine of 2 theta, close parentheses, then close parentheses, and then I'm going to go to zoom 7. Okay, so this one kind of looks like a rose curve, but it's not. It has the 2 petals though. It's called a lemniscate. Now, the thing about this is if I were to say get rid of one of these, let's say I get rid of the first one by clearing it, and then go to zoom 7, I still get the same graph. That's because of the symmetry. Okay, it wouldn't work like that if you were dealing with rectangular coordinates, but because of the symmetry it works here. But when in doubt, I would just go ahead and put the plus and the minus. Okay, that's going to be it for this video. We'll see you in the next video.